Hello everyone, I am Zixiang Xu, a Master Research student from University College Dublin. Today I am honored to share our project, an exploration of virtual reality for awareness of the climate change crisis, a simulation of sea level rise. Climate change is accelerating, bringing the world dangerously close to irreversible change. With the fact that the effects of climate change are gradual rather than immediate, large portions of the public still believe that global warming is not happening. Meanwhile, virtual reality and augmented reality technologies have been shown to achieve remarkable results in multiple fields and attracted more and more users. From 2017 to 2021, the number of AR and VR users on US nearly doubled. And according to relevant projections, there will be a stronger lift on AR and VR global education technology expenditure till 2025. Many researchers have been explored the possibilities of VR and AR in climate change topics. In 2018, Markowitz and his team designed and tested an immersive VR project for teaching the consequences of climate change through simulating an immersive underwater world to show the process and effects of rising seawater acidity. And in 2021, Giuliano's team provided a project of how three coastal communities have used VR to support communication and community outreach focused on sea level rise. They provided more simulations of sea level rise from a top-down perspective that's showing good feedback. Our project originated from this. That is, virtual reality experience plus climate change education. The combination would be an immersive climate change education method that has a better effect than the traditional mediums. Hence, we designed our project. Our project mirrors work from Giuliano's team that has been used to highlight the sea level rise, and this is targeted at sea level rise simulation and natural ecological information on local residential area. We picked the seaside settle located in North County, Dublin, called Portree. Our exploration originates from a 360-degree fixed scene that is combined with a 360 video and a simulated 3D ocean model. This method is easy to achieve a VR sea level rise experience and good to be a start point, but we realized that the fixed point limitation could not provide an immersive enough experience. Therefore, we decided to develop this simulated scene with Unity 3D and run it on the Oculus Quest platform. Unity 3D is a great game engine with mature development support to create virtual scenes and user interfaces. Oculus Quest has high portability, which can be an advantage to enhance immersive experience. It is also have a very mature and friendly development support. The user interface interaction are based on the laser pointed out from the hand controller. Concerned about human-computer interaction under virtual reality situation, buttons and other components are designed concise. We also designed the interface hidden function for a better immersive experience. This is a demo video for our project. As you can see, on the left side is the vision user get in the headset device, and the right side is the user who wearing the Oculus Quest headset. By click the point of interest on the map through laser from controller, the user can enter the first effective scene of that point of interest. User can interact with the slider and buttons to change the year of sea level rise simulation and move around using joystick or left controller. We also integrated the text information about the ecological environment into the user interfaces, which can be viewed through the multiplayer panel after clicking the corresponding icons. The sound effect of the sea tide had also been added to the scenes. Users can hear the change of the sound of the sea tide according to the level of the sea, so as to get a better sense of immersion. You can also get a compass on the user interface. It can do the real-time rotation based on the coordinate system and provide the direction corresponding to the real world when the user turns around in the virtual scene. The scenes of different points of interest can be easily switched in the project, and the new scene will be immediately loaded. The text information panel provides different ecological information of different points of interest based on the local ecological environment. For developing this project, we combine the prediction data files with the local digital evaluation model in QGIS to determine the results of sea level rise simulation from 2021 to 2100. Then, on the generated terrain model with DEM, the texture from satellite imagery is added to help constructing the residential objects. Then, with reference to local photos and the satellite imagery texture, the buildings and plans were modeled and put on the terrain model. Additional geographical and ecological information is added to the sub-panel along with sound effects. For the experiment and the future work part, because of the COVID-19, only one initial feedback session was done. We got positive feedback, but the sample is too small, so we don't think the results are strong enough to show. But we are organizing new experiments with more participants, and all 4 experiments are planned in Q2 of 2022. The experiments will also be conducted with local residents in Portland to test. Based on the user interface and the predicted geographical local information ocean, we also developed an augmented reality mobile application. The user interface of VR application and design structure logic are migrated from VR project in order to ensure the function consistency of the whole project. Then, the experimental survey content is being designed in order to learn the advantages and disadvantages of AR and VR respectively. The awareness change after taking climate change education through immersive experience is also one of the important directions we will study. Currently, the next step for this project is to evaluate an AR version of the application and subsequently explore if AR/VR is a superior media than other mediums for climate change education. We're also going to explore different human-computer interaction concepts based on VR and VR protest in climate change immersive education. New series of UI's development is started based on the current project. Many thanks for your attention.